One type of probe consists of a CT, usually wound with a convenient ratio of 1,000 to 1, so that 1 milliamp responds to 1 amp on the circuit being measured. The output can be measured by a multimeter or a millivolt meter with a suitable shunt. For example, 200 milliamps through a 1 ohm shunt would give us a reading of 200 millivolts. Another type of current probe is the Hall effect probe. This probe actually measures the effect of DC and AC magnetic fields around conductors. In this unit, an internal energy supply is required, so you must remember to check and change the batteries periodically. Although the input signal is current, the output of the Hall effect probe is actually a voltage signal, which can be measured by a DMM. You must remember to zero the output voltage before taking the reading. In this demonstration, observe the extreme variation in reading as the instrument gets closer to the magnetic field set up by the primary current. Note that this probe is subject to significant error when used in the proximity of magnetic fields from other conductors, for example in switchgear cabinets. It is evident that a magnetic field can significantly affect the reliability of the readings. All right, let's move on now to look at measurement of resistance. Most ohm meters work on the principle of injecting a small DC current, say 1 milliamp, into the circuit under test. By measuring the voltage drop across the circuit, the resistance can be calculated and displayed. It is important that the circuit be de-energized before attempting to measure resistance. Also, when measuring the value of a resistor in a circuit, you should always lift one lead so as to avoid the possibility of parallel current paths, which will of course result in a lower resistance value. You must take special care when measuring the DC resistance of an inductive circuit, for example a transformer